All right. So this question is going to ask, what is the minimum area of each member of the truss if it is made out of gray cast iron? Okay, so what do we have to do first for any problem like this? That's right, we've got to make a free body diagram. So that means this pin that's at B has to be replaced by its forces. So that's going to be a force in the X and a force in the Y. So I'm going to draw this one up. I'm going to call it FBY. I'm going to draw this one this way. I'm going to call it FBX. All right, the roller at A has to be replaced with a force. And it's going to be FAX. All right, so we've got our free body diagram now. So what we're going to do is we're going to use the equilibrium equations for the entire structure. So we're going to start with sum of the forces in the x direction is equal to 0. Okay, so I have FAX moving to the right. Right is positive, so I have FAX. The next one I have is FBX. It's moving to the left. So I put minus FBX. All right, and the last one that we have in the x direction is 3,000 moving left. So that's minus 3,000 equals 0. So right now you can see I have two unknowns. I have FAX and I have FBX. That means I can't do anything else with this equation. I can't solve it right now. So I go on to my next equilibrium equation, which is sum of the forces in the y direction is equal to 0. So I've got to look for all the things that are moving up and down. So I've got FBY, it's going up, so I'm going to say it's positive. And I have 2,000 going down, so minus 2,000. That equals 0. So I'm going to put 2,000 on the other side, and I'll get FBY is equal to 2,000 pounds. All right, so that's an answer already. All right, so the last one I have is my last equilibrium equation. It's sum of the moments, and I can pick anywhere. I'm going to happen to pick B this time, because it lets me get rid of two forces. So if I'm adding up my moments at B, I have to look at things that are going to create moments. FBY and FBX don't create a moment at B, because there's no distance. FAX does. And it's going to go counterclockwise. So I'll have FAX times its distance, which is 8. And since it's counterclockwise, it'll be positive. So I'll have 8 times FBX is my first one. I'm sorry, that's going to be FAX. All right, my next moment is going to come from this 2,000 going down, and it's going to cause this to go clockwise. And then since that's a y force, I need the x distance right here. So that'll be 6 times 2,000, and it'll be a negative. Okay, and the last one I have is this force of 3,000 pounds, and that will also cause it to go clockwise. So that one's an x force. I need the y distance again. That's going to be 8 times 3,000, and it's negative. That's all of my external forces. And it equals to 0. All right, so we're going to go ahead and solve this equation. I have 8FAX minus 12,000 minus 24,000 equals 0. So I'm going to combine those and move them to the other side, and I'll have equals 36,000, and I have 8 FAX. Now I divide by 8, and what do I get? To get FX is equal to 4,500 pounds. Okay. Now I'm going to plug this back into the equation for the sum of the forces of the x. I'll get 4,500 minus FBX minus 3,000 equals 0. Let me make sure I did that right. Right. Okay. So I have 45,000 minus 3,000 is a positive 1,500. I'm going to put that to the other side, so I'll have negative 1,500 equals negative FBX. All right, so now I need to get rid of the negative sign. So divide by negative 1, that gives me FBX is equal to a positive 1,500 pounds. All right, so now I've got all my external forces, which means I need to break this apart and find my internal forces. So we're going to start with joint A, just for fun. So what we need to do is draw joint A. So I'm going to label this drawing as joint A so I know where I'm at. I'm going to draw that one in tension. And I said FAX was 4,500, and I drew it to the right. So this is 4,500. This is AB. And I'm going to draw that one in compression, AC. I drew AB in tension, I drew AC in compression. So AB is going away from the joint, so it's in tension. AC is going towards the joint, it's in compression. So sum of the forces in the x direction equals 0. So 4,500 minus AC equals 0. That tells me I have AC is equal to 4,500 pounds. And since I drew it in tension and I got a positive number, this is in tension. I'll need that later whenever I'm calculating the structural strength or calculating the area that I need. Do sum of the forces Y equals 0. I have AB equals. So AB is a zero force member. It has no force in it, which means it can't be tension or compression. It's just AB equals 0. So the next one I'm going to look at is going to be joint C. You could look at joint B, but I just happen to choose joint C. So joint C looks like this. I have AC, which I already said was in compression, and it had a value of 4,500. I've got BC, which I'm going to draw in tension. I've got a downward force of 2,000 pounds. And I've got this force going to the right of 3,000 pounds, or going to the left, 3,000 pounds. So you can do any of the equations you want. Or can we? Yeah. Okay, so I'm going to do sum of the forces in the x direction equals 0. I have 4,500 going to the right. So that's positive 4,500. I've got 3,000 going to the left, so that's minus 3,000. And I have the x part of BC going to the left, so it's going to be not a minus. But I need to tell how much of the total it is. So if I come up here, I look and I've got a 6, 8 something triangle. Well, what I happen to know is that if I do a 6 and an 8 and I divide that by 2, I get a 3, 4. I know the last one's going to be 5. So the x part is going to be 3. The total part is 5. So that's going to be BC times 3 over 5. And this is equal to 0. So I get 4,500 minus 3,000. I'll get 1,500 minus 3/5 BC equals 0. Move the 1,500 to the other side. I get 1,500 equals negative 3 over 5 BC. I'm going to multiply both sides by a negative 5 over 3. I'll get BC is equal to, I don't know. Gotta have a calculator for that. 2,500? So I get 2,500 pounds. It's positive. That means this is in tension because I drew it in tension. All right. Almost through. All right, so the next step that we have in this problem is we need to find out what the area of those members have to be. So we can look up the structural properties of materials for that gray cast iron, and it says that we have an ultimate strength of 31,000 psi for tension. So sigma in tension is equal to 31,000 pounds. Sigma in compression is equal to 124,000 psi. Okay, so what we're going to do is we're going to use the forces that we got for tension and compression, and we're going to work backwards to solve what their minimum area has to be. So we're going to start with BC. So I'm going to say sigma BC is going to be the one in tension. So 31,000 is equal to the force BC, which will be 2,500, divided by the area that I need to calculate. So how I'm going to do this, I'm going to put in my calculator, 2,500 divided by 31,000, and I get that the area of BC is equal to 0.08 inches squared. Okay, and it's area, so it has to be squared. All area is squared. Okay? The other one we have is for AC, which was in compression, and that was going to be 124,000 is equal to 4,500 divided by A. So this is the area of AC. So I'm going to put in my calculator 4,500 divided by 124,000. I'll get area of AC is equal to 0.04 square inches. And that is this problem.